Okay, this is a little different because now I don't have a class in front of me, but I just wanted to finish this lesson. We were short on time today, so I thought we would, I would just do this. It's a little bit later, so hopefully somebody gets a chance to see this in geometry. All right, this is taken from the last theorem we just finished talking about. If you read the theorem, it says, in the same circle or in congruent circles, this time we're talking about the same circle, two chords are congruent if and only if they were equidistant from the center. All right, so what we've been given right here, and it says if and only if, so we can go the other way too. We can say this chord and this chord, if they are equal to each other, then those chords are equidistant from the center. What does that mean as far as distance? Well, if you remember, the distance between a point and a line or a line segment is that perpendicular distance. So if Wx equals xy, then the distance from Wx to point A is that perpendicular distance. And the distance from line segment xy to point A is this perpendicular distance right here. Now, what does it say? It says that they are equidistant from the center. That means that this distance right here, if Wx equals xy, and it is, okay, it's given that it's equal to each other right there, that means that this one, 5x, and 3x plus 4 are equidistant from each other. So all we do is just set them equal to each other. All right, so I'll just mark it so we can see that. So that means that these two are equal. If Wx equals xy, then these two segments right here are equal to each other. So we just do some math on it. We just go 5x equals 3x plus 4. We've been doing this kind of stuff all year. Subtract 3x from both sides. So 2x equals 4. Divide both sides by 2. Easy algebra. And x is equal to 2. But the question says, find AB, which isn't much more difficult. So x is equal to 2. AB is 5x. So we just go 5 times 2. Let's put AB right here. AB equals 5 times 2, which is 10. And that's it. That's all you have to do for that example. So it looks complicated, but it's really not that hard. It follows that example exactly the way we did in class. We just ran out of time to do this example right here. All right, that's it for that. Okay, here's another picture, and this is actually an example before the one we just did. And again, just because the class was a little short, we didn't do it in class. So here it is. It's on page 703. It's called example 4. And it's about a stained glass window. They call it a real world example, but I just kind of broke it down into just the important parts that we need to see right here. So it tells you that GH is 30, that would be the diameter. KM, this chord right here, is 22. We want to find JL, this little bit right here, okay, from the center to where those two lines or those line segments intersect each other. And that's what we're looking for. And you could call it anything. We can just call it X if you wanted to do that, just for that line segment right there so we know what that is. All right, so let's take a look, and we're trying to find this right here. Well, what do we know from the theorem that we learned about this situation? When you have a diameter or radius and it intersects a chord, let's say it intersects perpendicular, okay? So if it intersects perpendicular, that has to be true. It's not just any intersection. So if this thing was angled up like this, what we're going to say is not true. So the diameter has to intersect this chord perpendicular, all right? So you form a right angle. Now, if that's true, and it is because they were given in the picture that this is a right angle, so if they are perpendicular to each other, it does a couple things. First of all, it bisects KM. Now they tell us what KM is. KM is 22. So from here to here is 22. According to our theorem about this diameter bisecting this chord right here, that means that these two segments right here are equal to each other. So if the whole thing is 22, I don't think I need to write that out. We can just see it. That's 22. Then KL has got to be 11. So I'm just going to put an 11 right there. All right, so I know this side. I'm looking for this side right here. I have a right angle. What's kind of missing here? This hypotenuse. If we had a hypotenuse right there, that would help us out. Now, it's not in the original picture, but we have to use our imagination a little bit, all right, and say, okay, if I got two sides and I have a right angle, I should be able to find that third side. And that's what we're going to do right here. We're going to find this side right here. And we can actually find it. You say, well, they don't tell you what JK is. Up here, there's no JK. But what is JK? Look at it. It's a radius. It's a radius of that circle. Do we happen to know the radius anywhere else? All right, I mean the radius is going to be the same no matter where, but do they give us anything else? Well, look what else they gave us right at the beginning. GH is 30. GH, which is the diameter, okay, that's 30 inches. And so, yes, we do know the radius. The radius, GJ or JH, is going to be 15. All right, so that's pretty helpful. So we know the radius is 15. So from J to H is 15, but you say, well, wait a minute, I'm trying to find X. What's going on with that? Remember, the radius is the same no matter where. So JK is a radius as well. So this would be 15. From here to here, JH would be 15, and also from J to K. I don't really care about that J to H part. There's really no way I can figure out what that is. All right? Well, not right now. We can after we figure out the radius. So let's go from J to K. It's the radius, and the radius is 15. This is the diameter, which is 30, so the radius is 15. So I'm going to put a 15 right here. And check it out. I've got a right triangle now, don't I? I've got the hypotenuse is 15, I've got one of the sides is 11, and I'm trying to find this side right here. Once I find this side, I'm finished, and that's all I have to do. So now I've turned it into a right triangle, something I'm really familiar with. Now we can use Pythagorean theorem. It's not one of the special triangles, but that's okay. We can still figure this out. So let's do the math just to remind ourselves of the Pythagorean theorem. So it's x squared plus 11 squared equals 15 squared. All right. We'll just write it out. That's 121, and 15 squared is 225. Subtract a 121 from both sides. Shouldn't have to go through all this, but that's okay. And when you do the subtraction, that's a 1, that's a 0, that's a 4, so 104. Now x squared is 104, so x is equal to the square root of 104. Now this is inches, so we're okay throwing this into a calculator and getting a decimal approximation. So you chuck it in your calculator and you get, we'll put the approximate symbol, approximately 10.20. It seems like they kind of like rounding it to the hundredths place in things like this. So if they don't tell you, it really doesn't matter, but I think for the most part they'll tell you which way to round it. So it's 10.20 or 10.2 inches. Now the 0 is important. We're not going to get into that too much, but it says the hundredths place, so you still need the 0 there if they round it to the hundredths place. All right, and that's it. So we just found that length right there. It's 10.20. All right, that's it. So hopefully those two examples will help you out a little bit doing the homework. All right, see you tomorrow.